Hello students, welcome to this video tutorial on translating math statements to algebraic expressions note. So let's start with the chart up at the top in section A, math words. Okay, so we have four columns here. Words expressing addition, words expressing subtraction, words expressing multiplication, and words expressing division. So I've got one for each of these columns so far. So in the addition column, we have increased by. Okay, so let's add a few more. Okay, so how about added to? And we can always use plus. And how about a really sophisticated one? The sum of. Okay, so those are just four examples. Whenever we see addition, we can substitute addition for these phrases or these words. Okay, so let's go over to the words expressing subtraction column. We have the first one, decreased by. And then how about something very basic, subtract. A number subtract another number. How about reduced by? And a sophisticated one, difference between, the difference between a number and 10. And then perhaps a tricky one to use is subtracted from. Okay, let's go to the next column. Words expressing multiplication. We have multiplied by. And then we have a good one here, the product of a number and 4. And we can use double, we can use triple, we can use quadruple. Okay, let's go to the last column, words expressing division. We have the first one, divided by, and we'll go right to a sophisticated one, the quotient of. That's a good one, the quotient of. And if we are dividing by 2, then we could use the word halved, a number halved. Okay? So we're going to use this vocabulary in the next section as we translate algebraic expressions to math statements. Okay? So let's go on to section B with using these words here. All right. Let me get my pen ready. Okay. So let's start with the first one. Example 1, translating algebraic expressions to math statements. We've got 3 ways we can write it. There's probably 4 ways. There might even be 5 ways to write it. So the good thing about this kind of question is that it gives you a lot of options. So we have x plus 11. Well, what's x? X is unknown. So whenever you see a variable, whether it's a, x, z, it doesn't matter, you're going to substitute that for a number. Okay, so let's start right away on this line, our first example. So, number. Now, because it's addition, let's look in our additions columns for words. So how about we use the first one? A number increased by 11. Okay, and that's exactly what this algebraic expression means. A number increased by 11. So what's another way that we could say exactly the same thing? Okay, so how about we use one of a different expression or different words expressing addition. So we're going to start again with a number. Remember, it's an unknown number. A number. And then how about we use the second option, added. To 11. Now this constant here, this number doesn't change. So all of these are going to end up with 11. Okay? Now, Let's skip this one, and how about we write our last one using this phrase, the sum. Okay? So you notice how these say or. See, these mean the same thing, they're just different ways to say it. So how about we use the sum? So, the sum of a number and 11. Okay, so that's 3 different examples, all meaning the exact same thing, x plus 11. All right, let's go on to 2a. So, example 2, which is 2a. Now remember, 2a means 2 times a. This times symbol is invisible. Okay? So it's multiplication. So let's look for words expressing multiplication. So the easiest way to write this is probably, we always start with the most basic way. So how about 2 multiplied by a number? 2 times a means 2 multiplied by a number. Okay? So how about we use the second phrase here, the product? So let's go on to another example. Now for this example, we're going to actually write down 4 different math statements. Okay? So how about we use the product of 2 and a number. The product of 2 and a number. Okay? All right. How about we use this one? Because we can't use triple because we're not multiplying by 3. We can't use quadruple because we're not multiplying it by 4. So how about we write, this is pretty simple here. Makes you sound pretty smart too. Double a number. Okay? And then if we kind of reverse that, we can put a number doubled. Now you might be questioning this one, okay? And I'll show you why this one is completely okay. So double a number means 2 times a number. A number doubled means a times 2. Are these two essentially the same thing? Well, yes, they are, because they're multiplication. It doesn't matter what number we put first. Now, in terms of algebra, we always put the number first and then the variable second. So these two mean the exact same thing. All right, so if you're getting the hang of this, why don't we move on to example 3. 4 different ways to say this subtraction question. So in terms of algebra, this is 5 minus e. So let's take the most basic way here. So how about we say 5 decreased by, because that was kind of the first thing we had in our chart here, 5 decreased by, and what's it being decreased by? Well, it's a number. We don't know what it is. It's just this unknown number called e. 5 decreased by a number. Okay? So how about we use this? I want you to try and use this. The difference between. So how about for another one? The difference between, and what is the difference? Well, again, it's 5 and a number. The difference between 5 and a number. Okay? That's a good one to use. All right. So how about something even more basic than the first one, maybe? So how about 5 subtracted by a number. In fact, you can even say, even shorter, 5 subtract a number. But the reason why I put this statement here is because I want to set up the last statement. Okay? So I want to use this phrase here, subtracted from. So how would I write that? So how about a number subtracted from 5? Okay? So when you use the subtracted from, you actually have to switch the order of these terms. Okay? A number here subtracted from 5. So that's a really good one to use. I want you to try and use that in your homework. Okay? All right, let's go on to the last two algebraic statements. Number 4, y over 2. Now remember, whenever we have a fraction, it's a division question. So this simply means y divided by 2. So if you know that, then this is pretty easy, isn't it? Okay? So how about we write the most basic one here? A number, that's y, a number divided by 2. A number divided by 2. So I want to use that fancy term in the chart. I want to use the quotient. So the quotient is simply the answer of a division question. That's what it means. So the quotient of, now you got to be careful of the order here. Numerator first of a number and 2. The denominator comes last. The quotient of a number y and 2. Y divided by 2. Okay? And then the last one. Get to use this word. A number halved. Okay, that means divided in half, which means dividing by 2. So I like that when we can use that example. Okay, number 5 is what is called a multi-step problem. Because we don't have one operation, we have more than one operation, okay? So we have multiplication here, 3 times a number, and then we have addition here. So we have two operations, multiplication and we have addition. Okay? So let's break this down. So let's talk about the first part first. Okay, this part. So how about something easy? A number multiplied by what? 3. Then, that's a comma, then what? Added to, and what are we adding it to? Adding it to 4. Okay? A number multiplied by 3, then added to 4. Okay, so what's another way we could write it? Well, how about this? How about triple? Sorry about that. Let me try to make it neater for you. Triple a number. And then yes, I could write then added to 4, but I want to make it totally different. Triple a number, and then how about increased by 4. Okay? So again, there's lots of different ways that you can write these statements. These are not the only 3. All right, so now let's do the most sophisticated way, the sum. So how about I start that, the sum of, and then I'll just pause for about 5-10 seconds and see if you come up with the same answer I do. Okay, so I'm just going to wait. You don't have to press pause. I want you to finish that statement. Okay, so I got this, the sum of triple a number and 4. But if you had the sum of 3 times a number and 4, that's fine. If you had the sum of a number multiplied by 3, then added to 4, that's fine as well. Okay, so again, there are lots of options when you're converting or translating algebraic statements into math statements. Okay, so thanks for watching this video. Bye.